All right, as promised, our equal sign is gone and it's been replaced by a less than sign. By and large, we're going to solve linear inequalities the same way we solve linear equations, with one little asterisk that we'll talk about at the end. So we're just going to focus in, try to get all of our x's on one side, all of our numbers on the other. So I'm going to get all the x's over there on the left. I'm going to add 2x to both sides. All right, so that's going to cancel out that term. So I'll have x plus 2x is 3x. Still got a plus 4 on the left, and then a 7 on the right. And then let's move the 4 over to the right. So let's subtract 4 from both sides. And that's going to give me 3x on the left. 7 minus 4 is 3 on the right. Get the x by itself. We're going to divide by 3. And we get x less than a whole number for ones. All right, x less than 1. All right, so that's our answer. All right, and that's a perfectly good answer. In pre-calculus, we have a second way to write answers of inequalities like this. It's called interval notation. So I just want to show you how this is done. Let's think about that inequality x less than 1 on the number line. Let's shade that in. So remember how we do this. Put 0 there in the middle and 1 is to the right of it. And we would say x less than 1 means we want to shade to the left. So I shade the number line all the way to that left arrow, which represents negative infinity. And then at 1, I want to indicate that it's less than 1, but not equal to. So I want to include things like 0.99999, but not 1. So we put an open circle. If I had less than or equal to 1, we would put that filled in circle. All right, so looking at that shaded in number line is a really good way to get to what we call interval notation. Interval notation says the most important bits of information are those endpoints, that this answer goes from negative infinity to positive 1. So it lists them left to right, negative infinity, comma 1, kind of looks like an ordered pair. And then we're going to put either a square bracket or parentheses on the end of this interval. For this one, we're going to use parentheses on the 1. Okay. Parentheses is equivalent to that open circle. So any number that you put an open circle on, you would put parentheses on. If we had filled that in for a less than or equal to, you'd put a square bracket on the end of that. And then negative infinity, I'm also going to put a parentheses on. We always put parentheses on infinity and negative infinity because those are not numbers that you can be equal to, right? That's just kind of a concept out there, negative infinity. All right, so this is what we call our interval notation. All right, so that is an equivalent answer to that one up there. All right, before we go on to our next inequality to solve, I want to mention that little extra thing about solving inequalities. So I'm going to solve this inequality again and show you something that can happen. So I'm going to recopy this inequality, x plus 4 less than negative 2x plus 7. All right, so I had chosen to add 2x to both sides last time. What happens if we decide to get the x's over on the left? So if I decided to subtract x from both sides, right, then I would get a 4, a negative 3x on the right plus 7. Then we would have to subtract the 7 from both sides. So I'm going to subtract 7. And then I get, let's see, this is negative 3 less than negative 3x. Divide by negative 3. And on the left, I get a positive 1. And on the right, I get my x. All right, so we still got the same number 1, but we actually got a different answer. If you look at the answer boxed in on the left-hand column, I have x less than 1. X is on the small side of 1. On the right, I've got x on the big side of 1. X is bigger than 1. So which answer is correct? It turns out that our first answer was correct. And the reason why our problem happened here. When you divide or multiply an inequality by a negative number, you need to flip the inequality. Okay, so what I should have done is in this step, flip my inequality. All right, and that maintains the proper relationship between the variable and the number. All right, so anytime you divide or multiply an inequality by a negative number, you need to flip the inequality. All right, so that's really the only difference with our linear inequalities is if you kind of end up in a situation where you have to divide both sides or multiply both sides by a negative number, it does alter the inequality in that way. Let's try one more. All right, so here we have kind of a combination of our inequality techniques and that fraction technique. So remember with equations, I kind of scanned all the denominators and I found the least common multiple. So I've got 6, 3, and 2. Those all divide evenly into 6. So I'm going to multiply both sides of this equation by a 6. All right, so I'm going to distribute the 6 to both terms on both sides. So I'm going to get a 6 times 7x over 6 plus 6 times 2/3 greater than or equal to, let's see, 6 times 4, we'll just go ahead and multiply, that's 24, minus, I'm going to have a 6 times x over 2. All right, and then we just go through and reduce all those denominators, right? The 6's are just going to cancel each other out, equals 1. We don't even need to write that. The 3 times, excuse me, the 3 and the 6 reduce to 2. And then over on the right, 2 divides evenly into 6 3 times. All right, and then we just got to see what's left. So in my first term, the 6 is canceled, so I just have 7x. And then I've got 2 times 2 is 4. 24 was already done. And then minus a 3 and an x. So we didn't even need any parentheses. All right, so now we want to move all of our x's to one side. You might want to focus on trying to keep that coefficient positive so you don't end up dividing by a negative number. So if you want to do that, we would add 3x to both sides rather than subtracting 7 from x from both sides. And that leaves me with a positive x term. Okay, and then I can subtract 4 from both sides. And I get 10x greater than or equal to 20. Divide both sides by 10. And since that's a positive number, I don't need to flip the inequality. I'm just going to end up with x on the left greater than or equal to 2. All right, so again, perfectly good answer. I'm just going to show you how to write that one in interval notation as well. All right, so let's go ahead and graph that on the number line. So here's 0, here's 2. I want to say x greater than, so you're going to shade to the right. And because this one says or equal to, we're going to fill in that circle. Right? Interval notation always just writes the end points of the interval left to right. So we're going to say 2 comma positive infinity. I said infinities always get parentheses. You're never ever actually equal to infinity. And since we have that filled in circle on the 2, instead of a parentheses, we're going to put a square bracket, right? And that is equivalent to saying x greater than or equal to 2. All right. All right, that's it for linear equations and inequalities, and I'll see you in class.